Hello everyone, welcome to our channel Engineering Phantom. So last time we have done with SNM analysis of read operation. This time we are going to do the SNM analysis for a write operation. So let's go with it. So we have already designed a SRAM 660 SRAM cell schematic. So let's start. So if you don't know how to design this schematic, I have make a separate video on how to design schematic. You can watch it, and also separate videos for hold and read SNM. You can watch that too if you want. So let's start the SNM analysis for write operation. So let's start with ADL. First of all, we will give simulation values to first of all bit line bar. So will be pulse, DC value 1, voltage 1 0, and 30 nano, delay time with blank 10 pico, rise time all time 10 pico, pulse width will be 10 nano, and we are done with bit line bar. So our next signal is bit line, never, pulse, DC value 1 0, period 20 nano, delay, leave the delay blank, this time 10 pico, 10 pico, pulse width 10 nano. We are done with it. Next is word line, enable, pulse, DC value 1, so it will transit from 0 to 1, pulse, period, oh sorry, it's period 20 nano, then delay 10 nano, rise time 10 pico, hold time 10 pico, pulse with 10 nano. So we have done with word line signal. Next is ground, enable, we select DC. For ground we have to give 0, apply. Next is VDD. For VDD, enable, DC in 1 for VDD, apply. So we have done with analog signals. Now we have to add a variable. So variable is x, small x, as we given in DC voltage. So 500 milli. Okay, apply. So variable value is given. So let's do analysis. We will do DC analysis. Design variable, which is x, which will be varied from 0 to 1. So apply. Okay, now we have to do the signal for which we will do analysis. We will do analysis for Q and QB. So yeah, here we have get the data, add it. So now we can see it's added in each ADL window. Now we have to add initial values to the nodes. Coverage 8, initial condition. So here we gonna add 0 at QB, and 1, you again press initial condition, right here 1, then assign it to QB bar. So 0 and 1 were assigned, and so we will run the simulation. Till here the process is same like read SNM, but after that we will change. So here the half one is done. We will take it aside, y versus y, because I already told you I can't merge the windows, so I am using this way. So we have got the extra window. Now what we do here is a change for write SNM only. We have to do this, change this plotting mode from replace to new sub window. or we can do it new window. So let it be new sub window, and then go in analog stimuli, change the bit line bar from 1 to 0, apply, okay, let's see. So yeah, now we have to merge it. I'm doing extra step, you don't need to do, you can directly take the graph and merge it like this. So let me delete the extra graphs. One is deleted. Let's go with another one. Delete. Oh, see this. Yes. So yeah, all graphs are deleted. So here we can see the hold. Let delete. No, it can't be deleted. So here it is. So again, we press V to get the vertical lines. Yeah. Then I can move this with the help of cursor. Again press V. So I get another vertical line. Now I press H. Now I will press H again. So I get another horizontal line, and this way I got the square which is fitting inside this eye butterfly curve. So this is the noise margin of hold noise margin of 60 SRAM cell. To improve this hold noise margin, we can modify the cell pull-up ratio, which is basically ratio of pull-up transistor to excess transistor, by keeping it around 0.75 or around 0.65. You can do it or improve hold noise, right noise margin. Yeah. So this way we have seen how the right noise margin can be calculated. So I hope you understand it. If you have any query, you can post it in comment section. I will try to resolve it. And please, I have one request for all of you. Please like, share and subscribe my channel. It will motivate me to make some more such videos. I hope you guys support me. Thank you.